Okay, so today I'm going to talk about the quadratic formula and quadratic equations. Quadratic equation usually takes the form of an squared plus bn plus c equals 0. That's a quadratic equation, and even if you have something like an squared plus bn equals c, that's still a quadratic equation because you can rearrange that. If you subtract c from both sides, that just becomes negative on this side, and it works just as well. How can we solve this equation for n? The quadratic formula is a way of working this out. We know that if this is true, if an squared plus bn plus c equals 0, we know that n is equal to negative b plus or minus, that's right, there are two answers, the square root of b squared minus 4ac over 2a. And that seems quite complicated, and I'm going to show you how we arrive at that result. We use a couple of steps. We use completing the square. That's one of the main steps. What we do is we have b squared plus a squared plus 2ab, and we can shorten that down to a plus b squared. That's called binomial expansion in reverse. What we can do, for example, if we had a squared plus...
So just to be clear, so going from in the brackets to not in the brackets is expansion?
Yes, it is. So I suppose you could say that going back to the brackets is factorization, I guess.
Yeah.
If we had a squared plus, 2a, and we say that's equal to b, if we add 1 to both sides, that turns it into a squared plus 1 plus 2 times 1 times a, because 2 times 1 is 2, and we say that that's equal to b plus 1. Now this over here is the same format as this, with b being 1, because 1 squared is still 1, and therefore we can change that back into a plus 1 squared. And that is called completing the square. I'm going to demonstrate how we can turn this equation into this equation. Let's say we have, back from the beginning, an squared plus bn plus c equals 0. So what I want to do is I want to subtract c from both sides. So we have an squared plus bn equals negative c. And what I want to do is I want to change here from this format into this format. So I want to divide both sides by a. So we get n squared plus b over a n is equal to negative c over a. Then what I want to do is I want to take this, halve it, and square it, and then add that onto both sides. So now I have n squared plus b over a n plus b over 2a squared is equal to negative c over a plus b over 2a squared. All we really have to do is rearrange this slightly. I'm going to switch these two terms over, and with this one here, I'm going to halve it and then double it again. So what we're left with is n squared plus b over 2a squared, which is this, and then we plus 2 times b over 2a n. And that is equal to, again, negative c over a. We haven't actually made any changes to the value, so this side stays the same. And now, as you can see, this here is in this format, except with b being n and a being b over 2a. So we can change this down. We can factorize that down to n plus b over 2a squared is equal to negative c over a plus b over 2a squared. Now we're very almost there. All we have to do now is square root both sides. So we are left with, let's start over here, n plus b over 2a is equal to the square root, let's ignore that, the square root of negative c over a plus b over 2a squared. There we go. And if we just subtract this from both sides, we are left with almost, very almost, our final answer of the square root of negative c over a plus b over 2a squared, and then out of the square root, subtract b over 2a. And now all we have to do is rearrange this slightly. So if we were to somehow make it so that this fraction here and this fraction here have the same denominator, we could combine them into one fraction, and then we could, instead of square rooting the entire thing, just square root the numerator and square root the denominator. So what we're going to do to this is we're going to expand this, so it's equal to root of negative c over a plus, and then we're going to expand this, so that's b squared over 4a squared minus b over 2a. And then what we need to do is just multiply the numerator and the denominator of this by 4a. So we're left with the square root of minus 4ac over 4a squared plus b squared over 4a squared, subtract b over 2a, and I'm going to move on to a different page because we are running out of space here a little bit. So we're left with n is equal to the square root of negative 4ac plus b squared over 4a squared, and then it's minus b over 2a. And due to the way square roots work, that's also equal to the root of 4ac plus b squared all over the square root of 4a squared, which is 2a, and then we subtract b over 2a, and now we can combine these fractions, negative b because minus b, and this square root is actually plus or minus the square root due to the way square roots work, i.e. 3 squared equals 9, and also negative 3 squared equals 9 as well. So if you had the square root of 9, that's equal to 3, but it's also equal to negative 3. Due to convention, we would say that root 9 is 3. If we wanted to find all the possibilities of numbers that when you square them give us 3, we would say plus or minus the square root of 9. So this square root up here is actually plus or minus this. So we have negative b plus or minus the square root of, I'm just going to rearrange these slightly because of convention, square root of b squared minus 4ac all over 2a. And that is our equation before. That's the quadratic equation. So I'm just going to give you a little example of when this would be used. Hopefully I don't have to break out the calculator too many times. But let's say we have 5n squared plus 3n plus 17 equals 0. I have a feeling this is going to be a complex number, which is a bit of a pain since we haven't done a video on complex numbers yet. But I think we'll get one up soon, and then we can link to that right here. In fact, yeah, over here. We'll do some editing magic. Follow the first step. We know that n is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. Now let's just plug all of our numbers into the equation. B is 3. That should be negative 3 plus or minus the square root of negative 3, of 3 squared minus 4 times 5, which is a, times 17 over 2 times 5. Alright, now let's just do all these multiplications. So we get negative 3 plus or minus 9 minus 20. 20 times 17. Testing my mental arithmetic is going to be... We checked on the calculator, it is actually 340. And we divide that by 10. Now, 9 subtract 340 is negative 3 plus or minus square root of... okay, so what we do is 340 minus 9, and then we multiply that by negative 1. So that is going to give us 331. So square root of minus 331 over 10. And that gives us... Ooh, okay, we're going to break into complex numbers here. So, plus or minus the square root of 331 times I. I is, of course, the square root of negative 1. And I'm going to have to break out the calculator for this one. So that's roughly 18.19. So let's have some curly equal signs to say that it's not exact. We really should have planned this in advance, actually. So, 18.19, I said. 18.19i. Oh, that should be over 10, and that should be over 10. So, we have negative 0.3 plus or minus 1.819i, which gives us the two answers of 1.519i, and we also get negative 2.119i. So those are the two answers that if we plugged into our equation here, this would be correct. And that's an example of how we use the quadratic equation and quadratic formula.